So let us discuss some of the factors, important factors to define the superconducting state. And as I told, the critical temperature, critical field, and so let us discuss all about this. See, the superconducting state, it is defined by the three very important factors, that is a critical temperature, critical field, and the critical current density. Each of these parameters is very dependent on other to the properties present. Already we have some of the properties, but these parameters, they are very dependent on the other two properties present. So here, see the critical temperature, the temperature at which the material electrical resistivity drops to absolute zero, it is called as the the critical temperature or the transition temperature, as I told before starting of the unit. Okay, so the temperature at which the material electrical conductivity drops to absolute zero, so that temperature we call it as a critical temperature or the transition temperature. Below critical temperature, as I told, the material is said to be conductive, superconducting, and above the it is said to be normal state. Below this temperature, the superconductors are also exhibits a variety of several astonishing magnetic and electrical property. So some of the metals, here see the table. So some of the metals, they are having the critical temperature. See, for different metals, the critical temperature, it is different. The aluminum, it is having 1.2 kilo Kelvin, tin it is having a 3.7 Kelvin, and as mercury, it is having 4.2 Kelvin critical temperature. So next, so that is electrical resistivity versus temperature plot for the superconductor and the normal state. See here, for this is the superconducting state, and this is for the normal state. From the figure, it can be seen that the electrical resistivity of normal state decreases. See, for the electrical conductivity for the normal state, it is decreases that is steadily as the critical temperature. See for this here, and as the temperature, it is decreased. See, as the temperature, it is the electrical resistance or resistivity of the normal metal decreases steadily as the temperature, it is decreased, and reaches a zero value at 0 Kelvin, called as the residential resistivity. So it will reaches to that is, as the temperature decreases, then the resistivity also goes on decreases steadily. So it will reaches to the 0 Kelvin, and called as the that is a residual resistivity for the normal state, we can say. See, then coming to this is all about the critical temperature or the transition temperature. Now let us second parameter, that is a critical magnetic field. See, above this value, so above this value of an electrical externally applied magnetic field, a superconductor behaves as a non-superconducting. So this minimum magnetic field required to destroy the superconducting state, and it is called as the critical magnetic field. So above, what happens, the minimum magnetic field required to destroy the superconducting state, means whatever the superconducting state we get, so it by applying the minimum field, so that superconducting state, it is destroyed, and this and that magnetic field, that we call it as the critical magnetic field, and it is denoted by the that is a HSC, and this is the the graph indicates the temperature versus the magnetic field, that is a B, external magnetic field B naught. And now next, that is current, that is electrical current density. So that is the maximum here, the maximum value of the we can say that is electrical sorry. So as I told, that is critical temperature, and so electrical current density, this is the maximum value of the current at which the superconducting state. Okay, so this is all about the that is some of the parameters of the superconductors. So next let us move to the what that is another type, the types of the what that is that is types of superconductors. There are two types of the what the superconductors. One is that is a type 1 superconductors, and another is the what type 2 superconductors. See, in type 1 superconductors, see the superconductor when placed in a magnetic field excludes the what the magnetic field completely from the interior of the body till the body attains the what the critical value, that is Hc, the critical field, magnetic field, and it is called as the type 1 soft superconductors. See, type 1 superconductors, there are two types of the superconductors, type 1 superconductor and type 2 superconductor. Type 1 superconductors, they are called as the soft superconductors, and type 2 superconductors are called as the hard superconductors. Soft superconductors are those which can tolerate impurities without affecting the water superconducting properties. As I told, by applying by adding the impurities to the superconductors, the superconducting state, it is transmitted to the the normal state. So in case of the soft superconductors, there is no effect by adding of the the impurities for the soft, that is a type 1 superconductors. There is no effect on the the superconducting properties. So because of that, they called as the soft superconductors. Only one critical field exhibits for these superconductors. It requires only one critical field, and here critical field value, it is very low in case of the the type 1 superconductor. And here that is, these conductors show complete Misner effect. So here these superconductors shows the complete Misner effect, and the exhibits the perfect and complete Misner effect, and the current flows through the that is flows through the surface only. So here in case of the that is a type 1 superconductor, the current flows through only through the surface, and these materials have the limited technical applications because of very low field strength value. So there are only limited technical applications for this type 1 superconductors because of the very low field strength value. For example, that is mercury, zinc, and the that is Pb, that is tin. Now let us discuss about the type 2 superconductors. See, these are called as I told, these are the that is hard superconductors, that is hard superconductors. The another name for the that is a type 2 superconductor, it is a hard, are those which cannot tolerate the impurities, that is the impurities affects the the superconducting property. So here by adding the impurities, the properties of the the superconducting, it will affect on the the properties on the the superconductor. See, here it is having two critical fields. As I told, in case of the type 1, it is having only one critical field, but it is having the two critical field, that is Hc1, that is a lower field, and the upper field. So lower field and the upper field, there are two fields in case of the that is a type 2 superconductors, whereas in case of type 1 superconductors, only one field, the two lower field. So here the critical field value, it is very high. Though it will not exhibit perfect and complete Misner effect. It will not exhibit the that is a it does not exhibit a perfect Misner effect. See, because the magnetic field is completely pushed out of the material, and the lower critical field is lower critical field. So why it is having the as I told, lower critical field. What do you mean by that lower critical field? So here the material is a perfect diamagnetic, and hence the magnetic field, it is completely pushed out of the the material, and so because of that, it is called as the a lower critical field, and within this region the perfect Misner effect does here occurs. Above this, we does not exhibits the that is a Misner effect. So here, and the next that is it is found that the current flows out throughout the material. But in case of the type 1 superconductor, the current flows through only on the surface. But here it is found the current flows throughout the material. So these materials have wider technology of a very high magnetic field strength, that is a value. The value of the, see here, this is the differences, or we can call it as that is a types of that is a superconductors. See the graph as shown in the figure. So this is the type 1 superconductor and the type 2 superconductor, the applied magnetic field and here induced magnetic field. So as the induced magnetic field, and this is for the normal state, and here this is the superconducting state. But in the type 2 superconductor, so superconducting state this is, and the that is mixed state. So this is the normal and the mixed state. So this is completely so this is completely normal state, and this is the superconducting state. But here this is this is all about normal, and this is also normal, but this is a superconducting. But this part, it is here again it is the mixed state, that is a normal state and the superconducting, because it is having a two critical fields. So because of the it is having a mixed field. See, and as I told, low critical superconductors, high critical superconductors. See, superconductors that require the liquid helium coolant are called a low temperature superconductors, and superconductors having their critical field values above the temperature of the liquid nitrogen are called as the high temperature superconductors. So the liquid helium temperature, as I took, the critical temperature is 4.2 K above the absolute field. So we can see there are wide applications. So in the next video, let us discuss about the wide applications of the superconductors.